Good morning, physics fans. How we doing on this fine Tuesday morning? A little chilly outside. It's okay. Might get a little chillier later in the week. Hopefully we'll keep our fingers crossed here that they will not, that the weathermen are wrong. Today, the only thing we're going to go through is we're going to go through a problem. First problem from the extra problems I gave you yesterday because I goofed up in the solution. My latent heat of fusion. I use the latent heat of vaporization when I transferred the ice to water. That's why if you try to go through the problem, you had it incorrect. That was my fault. I used the wrong constant here for the heat of fusion. I used 2.26 times 10 to the 6, which is latent heat of vaporization. Slight mistake. But what we have here is how many joules of heat are required to raise 20 grams of ice at negative 10 degrees Celsius to water at 20 degrees Celsius. We want to know how many joules of heat are required to do that. So what happens in this, as we go from this, is we start as ice. We start at ice at negative 10 degrees Celsius. We have to transfer that to ice at 0 degrees Celsius. And how we do that is using our MC delta T. From that, we have to go from ice at 0 degrees Celsius to water at 0 degrees Celsius. So we transfer from ice at 0 degrees Celsius to water at 0 degrees Celsius. And how we do that is by our heat of fusion times our mass. And then from this point, we have to take it from water at 0 degrees Celsius to water at 20 degrees Celsius. And once again, we could do that by using MC delta T. So if we take a look, we have our specific heat of ice is different than specific heat of water. We have a mass of 20 grams. So we need to make sure, because we're dealing with units of kilograms here. Okay, we need to make sure we get into kilograms. So we have 0.02 kilograms as our mass. So to find the number of joules for our first, we have our mass 0.02, our specific heat for ice, which is 2060, and our delta T is final minus initial. Now we have to make sure that we have minus an initial there. Got a little boom chain going on. So we have 0.02 times 2060 times the value of 10. To change from ice to water at 0 degrees Celsius, we have to take our heat of fusion times our mass. So we have 0.02 times our heat of fusion, which is 3.33 times 10 to the 5th. And then finally, we have our last, which is our MC delta T. We have to take water from 0 degrees Celsius to 20 degrees Celsius. So we have 0.02, our mass, times our 4180, because now we're dealing with water here. And then we have our final, which is 20, minus our initial, which is 0. So we have 0.02 times 4180 times the value of 20. So now it becomes a clickety-clack calculator exercise. 0.02 times 2060 times 10. We have 412 joules. We have 0.02 times 3.33 times 10 to the 5th. So we have 600 6,660 joules. Then we have 0.02 times 4180 times 20. So we have 1672 joules. And to figure out the amount of heat, we just have to add these together. So we add plus 412 plus 6660, and we get a total of 8,546 joules. Once again, I botched this up because I used heat of vaporization rather than heat of fusion. That was my mistake, and I'm sorry about that. Hopefully he didn't sit there and go, man, I don't get what he's doing. I don't get any of those answers. Okay, this is the correct way of going about doing it. Sometimes you'll see 3.34 here times 10 to the 5th joules. Sometimes you'll see 4186 there with respect to water. There's all types of different constants. A lot of it depends on when you have different solutions of water. If it's salt water, it's a little bit different. If it's at different temperatures, you're going to have different specific heats. So it will vary and range with the values. Okay, what I will do also is I'm going to post some homework problems for you to start working on. Tomorrow we'll come in, we'll start, I'll maybe go over another problem or two tomorrow, get a review sheet for you. Look to do a chapter test on this at the end of this week. We have no other new material to go over with this material, so that's how the week's going to play out. The rest of the week, like I said, I'll come in tomorrow, maybe do a problem, just sort of like we did today here. If you have questions, you have something you'd like me to be able to do, that's fine. I will go through it. Other than that, I have nothing else for you today. I hope everything's going well for you and your household and your family. Hopefully you keep your social distancing. I miss you guys, but we'll get back to some sort of normal here soon. Other than that, adios. Start working on your homework, and like I said, we'll have an evaluation later in the week. Please ask any questions. If you have any questions, please do ask. We'll see you. Have a great day.